In this tutorial, you will learn how to balance a reaction equation after you have written it. Now, the reason why equations must be balanced is because of the law of conservation of mass. If you look at this equation, this is how water is formed. H2, which is hydrogen gas, plus O2, which is oxygen gas, yields H2O, which is water. If you look down here, you see that H2 is 2 hydrogen atoms, O2 is 2 oxygen atoms, H2O is 2 hydrogen atoms and 1 oxygen atom. So we have 2 hydrogens before the reaction and 2 hydrogens after the reaction. But before the reaction we had 2 oxygens, and after the reaction we only had 1 oxygen. So we cannot use this reaction equation as it's written because it is violating the law of conservation of mass. One of the oxygens has disappeared. So that is why we have to balance the reaction equation. We use big numbers out front called coefficients in order to tell us how many of each compound we have to put in to get a balanced equation. So in this case, we are going to add more oxygen to our product side by putting a big 2 in front of H2O, and what that does is it gives us 2 oxygens because we now have 2 H2O molecules. So we've added a second H2O molecule. However, that has now given us 4 hydrogens. So we have to go back to the first side and we have to add a second pair of hydrogen molecules. So we put a big 2 in front of the hydrogen. So now we have 1, 2, 3, 4 hydrogens on the reactant side, 1, 2, 3, 4 hydrogens on the product side, 2 oxygens on the reactant side, and 2 oxygens on the product side. Now we have a balanced equation. This is how water forms. Now it can get pretty cumbersome to be drawing all of the elements out. So I'm going to show you a method to balance the equation that doesn't require you to do all that drawing. Now the first thing you're going to do is you're going to get a written equation. Now you have to have the equation written correctly with all of your crisscrossed and subscripts done correctly, or your balancing will not be done correctly. And the first thing you're going to do is you're going to draw squares around every individual compound or element in the reaction. So everything that's separated by pluses and arrows gets squares around it. And the reason why we put squares around it is so that we remember the rule that we can never, ever, ever, ever change any of the numbers inside the squares. All we can do is put numbers outside of the squares, and that will increase everything inside, but you can only do that all at once. Now our second step after we've drawn boxes is to make an element inventory. That is where we put down every single element that we see in the equation on the left side and the right side. So here we have sodium and a hydrogen and an oxygen, and we see the same elements on the right side as well. Now the inventory is how many we have of each. And the inventory is separated into 2 columns. One column is for your reactant side, which is everything before the arrow. One column is for your product side, which is everything after the arrow. So we're going to add up the total number of each atom on both sides. Here is sodium on the reactant side, and there's only one of them because there's no numbers after it. So we're going to write a 1 in our inventory. Here is sodium on the product side. It appears nowhere else, and there's only one of them, so we're going to write a 1 on the product side. Here's hydrogen on the reactant side, and there's a 2 after it, so that means there's 2 of them. So we're going to put a 2 on the reactant side for hydrogen. Now on the product side, here is hydrogen, and there's only 1 of them because there's no numbers after it. But wait a minute. There's hydrogens here too. So we have to add together these 2 hydrogens plus this hydrogen for a total of 3 hydrogens on the product side. Now for the oxygens, there's 1 here in the H2O. So we're going to put a 1, And then on the product side, we only have 1 here. Okay, so now that we've made our element inventory, our next step is to put numbers in front of the boxes. The numbers in front of the boxes multiply everything inside the box. And we put numbers in front of the boxes and update our element inventory until all the numbers in our R column match all the numbers in our P column. Now right now the sodium numbers match and the oxygen numbers match, but the hydrogen numbers do not match. We have 2 on the left side and 3 on the right side. So we need more of them on the left side, on the reactant side. So to do that, we are going to put a 2 in front of the H2O. The 2 in front of the H2O will multiply everything inside the box times 2. So H2 times 2 is 4. So now we have 4 H's, but it also multiplied our O times 2. And 2 times 1 O is 2. So now we increase the O to 2. Now if we go on to the right side, in order to get 4 H's, we have to put a 2 in front of NaOH, and that will give us 2 H's. So 2 H's plus these 2 H's is 4. So I put a 2 in front of this box. So that means I now have 2 H's. And I have to add them to the 2 H's in our hydrogen, H2. So 2 plus 2 is 4. Now I also put a 2 in front of the O. So that's going to increase the O to 2. And then I also put a 2 in front of the Na. So that's going to increase our Na to 2. So our oxygens are now balanced, our hydrogens are now balanced, but now our sodiums do not balance. We need more sodium on the reactant side, so we go back to the reactant side. And here's sodium. In order to get 2, we put a 2 in front, and you get 2 sodiums. So now we have 2 sodiums on each side, 4 hydrogens on each side, 2 oxygens on each side. We have our completed balanced equation. So 2 Na plus 2 H2O yields 2 NaOH plus H2. We didn't put any numbers in front of H2, so that's an imaginary one. We just write it at as is. And here is our finished, completed balanced equation. Now for our second example, we have silver 1 oxide yields silver plus oxygen gas. So our first step is to draw boxes around each individual substance in our equation. Everything separated by pluses and arrows. Then our second step is to do our element inventory. We only have 2 elements here. We have silver and we have oxygen. So that makes things a little simpler. So for our reactant side and our product side, we have 2 silvers and 1 on the product side. In our reactant side, we have 1 oxygen, and on the product side, there's 2 oxygens. So neither thing is balanced at this point. So we need to put some numbers in front. So we have 2 and 1. So in order to get that balanced, we need to put a 2 in front of the silver on the product side, which brings that up to a 2. Now that balances. Now we need to balance what is on the reactant side for the oxygen. So here we have 1 and 2 here. So we have to double it. So we put a 2 in front of this compound because that's where the oxygen is. So by doing that, we double the oxygen from 1 to 2. But wait a minute, we also doubled the silver because it's in the box as well. So we started off with 2 silvers times 2 is 4. So now our silvers are back out of balance. So we have to go back to the product side and we have to remove the 2 that we put there because now we need 4 of them, so we're going to put a 4 in front of it. Now we have 4 silvers. So 4 silvers on both sides and 2 oxygens on both sides. So our equation is balanced. So 2Ag2O yields 4Ag plus 1O2. And that is our completed balanced equation.